Hello, my name is Patrick White, and I am a student of web development at Austin Coding Academy. My path is full stack development for JavaScript. What I'm going to start here are, well, maybe got to start. This is my first video, but what I'm thinking of doing is starting a series of whiteboarding challenges using some of the websites like HackerRank and Code Wars, so that if you're a employer and you're considering hiring me, this could give you a peek behind the scenes, see kind of a glimpse into my problem solving or technical JavaScript skills. So far, my plan is all of the challenges that I'm going to do, it's going to be my first time seeing them. I'm not sure if there's any way to prove that, so hopefully you can just take my word for it. My solutions, I seriously doubt, are going to be the perfect solution. So, and if I'm ever, doing a problem that I've solved before and I just want to record it to present it, then I'll be honest about that. So, anyway, I'm going to do Code Wars because I think the difficulty scale is really nice. It's HackerRank. I think they go from what I consider medium to very, very undoable. So, all right. So, and since this is my first one, and I also just want to mention another reason why I'm doing this is just for my own benefit. Since I'm recording this, puts a little bit of extra pressure on me to solve it, or it puts a little extra pressure, just like a interview might. Let's see. So I'm wondering between the level 6 might be a little bit challenging, but let's go ahead and jump to it. Let's see. Let's start with a medium, maybe hardish one. We'll see. All right. So there's a queue for the self-checkout tills at the supermarket. Your task is to write a function to calculate the total time required for all the customers to check out. All right, our input is customers, an array of positive integers representing the queue. Each integer represents a customer, and its value is the amount of time that they are required to check out. So right away, I'm kind of thinking we're looking something like this. The number is the time that it takes for them to check out. All right. So that's part of the input. And a positive integer is the number of checkout tills. So I'm guessing that's assuming that's like checkout aisles. Huh. Okay. So 3. Output, the function return integer, the total time required. So let's see. Some examples would be helpful here. I'm not 100% sure. So if there's only one till, one aisle, then it'd be 5, 8, 4, so 12. Because there's when there's one till, total time is just the sum of the times. If it's 2, let's see, we should return 10. Because there are 2, and the second and third and fourth people are in the queue to finish before the first person has finished. Oh, okay. So basically, what's the longest time? Okay, that's interesting. So we want to know how long does it take for all of these people to finish. In this case, it'll still be 10 because these people will finish, and then this guy will still have 2 left. And so it'll be 10. Let's see, 2, 3. Let's see, 2, 3, and 10. So, 2 tills. Why would that be 12? Because I'm thinking if the 10 guy goes in one queue, do we know which people go in which queues? If we put the 10 guy in one queue and the 5 people in the other, then that should finish in 10. There's only one queue serving many tills, and the order of the queue never changes. And the front person in the queue proceeds to a till as soon as it becomes free. Okay, okay, so there's two queues. Okay. So there's two queues. So first, 2 guy goes in the 2 queue, 3 guy goes in the second queue, and then when that queue opens, the 10 guy goes in. So that's why it's 12. So, So it's a little bit, to me, I think it's a little bit complicated. But let me think about how did I just solve that right now? So I imagine there's two aisles, just like a real situation. 2 guy goes in to the empty aisle, 3 guy goes into the other empty aisle. And then as soon as the 2 finishes, man, a lot to keep track of here. So there's only one queue serving many aisles. The order of the queue never changes. The front person in the queue. You should assume that all test input will be valid, specified above. Situation as kata can be likened to more computer science related idea of a thread pool. Well, that's not good. Interesting. Well, that might be challenging. I don't know what a thread pool is. This might not be a great start. Computer for thread pool is a program, software design pattern for achieving concurrency of execution in a program, often also called a replicator worker. Model contains several threads waiting for tasks to be allocated to a concurrent. Well, I'll tell you what. I'm just going to kind of take a stab at it, and it might not succeed. But I already set the recording going. Okay. So we know the number of tills. So I'm trying again in my head. I feel like we need a variable, maybe a variable for every number that's in the queue. Let me create my own sample input and output. 3, 5, 7, 4 with 3 queues, 3 tills, aisles. So first 3 goes in, then 5 goes in, then 7 goes in, and as soon as 3 finishes, 4 goes in. So so this will take 7 minutes. So it would take 7 minutes. So how do I replicate that? Here we're doing a summing. Perhaps you create an empty array for every number, because that's basically what I did here. I created a spot to put these numbers in. Not sure how to create multiple empty arrays given a number. If I have n, how to just create n empty arrays. Oh, I guess you, okay, sorry. But in any case, let's suppose you create an empty array for each n. So if n is 3, I created 3 empty arrays, and then I loop and I say, give me if an array is empty, put it in that array. So 3 goes in that. 5 says, if the array is empty, push it to that array. That array is empty, push it in that. If the array is empty, push it to the array. That array is empty, push it to that. And then what's the next logical step? Is it necessarily going to go to the next array, or is it going to go to the array with less people in it? I'm going to assume that it's going to go, well, I'm going to assume that it's going to go to the array that has the smallest number, because that's what a person would do, and generally. So that's why 4 goes to that array. And that's actually, that's what the example 10, 2, 3, 3. I guess the 3 said, well, that's 10, that's 2, that's smaller. And the 3 said, well, that's 10, that's the sum of those two, so that's smaller. So if all arrays have an item, go to the array with the smallest sum of items. If an array is empty, go to that array. So that should basically, I think that kind of makes sense. And so I guess now the only thing to do is sum each array and return the largest sum. Sum each array, return the largest sum. The largest sum, yeah. Oh, so still kind of my biggest hang up is taking an n and then creating, well, an array of an arrays is a 2D array. Okay. So start out with an empty array. For n, create an empty array. Okay. So basically what that means is for let n equals 0, not n, let I equal 0. I is less than or equal to n, and I plus plus. Okay. So for each n number of times array, where's our empty array? Start with an empty array. Let's call it tills equals that. Tills add array, tills dot push let tills dot push empty array. Yeah. Huh. Okay. So when n equals 3, if n equals 3, actually we'll start this at 1. If n equals 3, I equals 1, make an empty array. So at the end of this, we'll have an array, and I'll have 3 empty arrays. So what did we say? We said, okay. So we basically did step 1. If an so now we have our aisles set up, our tills set up, and so now we go to the queue. So for each item in the queue, look at each item in the array. So that's going to look like something like for let I equals 0. Still using I because the first loop just set up those arrays. We're not worried about that. I is less than customers.length. Customers is the array, and I plus plus. So for each customer, look at each queue. Let j equals 0. J is less than tills dot length and j plus plus. And I'm going to make a note here. Even though I'm going to try to kind of calculate the complexity at the end of it. I'm not terribly worried about the whole inner nested loop with this. I'm not terribly worried about that just because, well, I guess with the examples given, it doesn't. Well, I guess it could be an issue. It depends. You're going to worry about. You're probably going to multiply the customers times the customers, the length of the customers array plus times this number here. I guess so this one. Wait, what is that? Okay, that's what that equals. So there's that consideration. I hope it's not a terrible issue. It's possible there's a better solution. Anyway, like I said, I'm just going to take a stab at it. So I guess you could say this is kind of like my naive solution, or this is just brute force solution, whatever. Yeah, so for let j equals 0, j is less than, so each customer now with his items is looking at each array, and I'm still commenting. I guess I could maybe start coding, but if it's kind of annoying. Okay, so this is tough. This is tough because obviously if the array is empty, if the array is empty, that's a simple solution. Just go to the first empty array. But what we said was that if an array is that if an array is if an item is if it's not empty, go to the array with the smallest sum. And I don't know if, I suppose you could sort the arrays at the end of the loop. At the end of, let's see, it's empty, push it. And then at the end of that, sort the arrays by sum. Huh. I'm pretty sure that's what it wants you to do. That would equal 10. This one would equal 9. 2, 2, 3, 3, 4, 4. It's a little I'm pretty sure because this one, which one was the one that equaled 10? That one equals 10. So that this guy went to the queue with the smallest line. So when would you sort? I can do merge sort by hand, but I think for the purposes of this, and especially since it's a pretty tricky problem, I think I would, in this case, maybe just use merge sort. But even that is not going to be super well. Array.merge, array.sort. Okay, so let's just keep going here. So what are we doing? So we're looking at the arrays. If array dot if we're looking at tills, if tills at index j dot length equals 0, tills at index j dot push wait. If we're constantly sorting the arrays by their sum, then we don't need to look at each array. We set up the arrays, and then we set up the arrays. They start out as empty, and then we go through each one, and we push the array. We push it to the first array, and then we sort them by their sum. So so this is where we started this whole process. So we don't need this. If that's the case, then we don't need this loop here. We're not going to look through each array. We're just going to we're just starting off our for loop here. So for each item in the array, array dot, so customers dot length for each item in customers dot length, and then we have our tills array. Customers at index I dot push sorry, I'm writing this incorrectly. Tills dot put tills at index I dot push. Why am I confusing this? Tills at index 0 dot push customers at index I. So it's for each person, we're going to put them in the first till. And after we put that in the first till, we want to sort the tills by smallest sum. Okay. So sort tills by smallest sum. So if we wrote a sort function, now I know I could do merge sort by hand, but I'm not sure how to do it with this whole array sum. Sort the tills by the smallest sum. So for the right now, I'm going to write a sort function. Function till sum. Const till sum equals. Okay. So all sort functions take an A and a B. And basically, so usually if you make it small to big, as you say, return A minus B. But we want to sum each, return the sum of each array. So we want, let a sum equal, because A is an array dot reduce current accumulator current return current plus accumulator current accumulator let a sum reduce okay. Let sum A equals that. Whoops, I lost something here. There we go. Let B sum equal B dot reduce current accumulator. Trying to get back some energy. I was kind of current plus accumulator. So these will return it'll take A and a B, and then we have a B sum and A sum, and then I'll say return A sum minus B sum. And this is going to sort them in ascending order. So the, oh, never mind. Sorry. A sum minus B sum. I had a thought to myself about using some kind of min value where you take in multiple values and it returns the smallest. Actually, that probably wouldn't be a terrible idea. One thing I don't know is, can math.min, can it take multiple values? So anyway, I think I'll just stick with this. Okay, so that's the till sum. So now that's kind of my sort mechanism. So so we added the customer to the first open till because that's the one with the smallest sum. And if it's empty, then it's going to be empty. So now we say tills dot sort till sum. So once all that gets done, now we have our arrays. So now the question is, so if this till sum, oh, that's right. Okay, so we already sorted them by smallest to largest. So at the end of it, what we want to return is the largest sum of all the tills. That's, I'm pretty sure, how I understand it. The largest sum of all the tills. In this example, the largest sum is 5 because there's a bunch of tills. In this example, it's 9 because they're all equal. That's interesting. Queue time, no customers, 1 till, 0. I'm pretty sure that this logic would work the same way because the sum of an empty array would be 0. I think. I'm guessing that's how the reduce function would operate. So what's next? So the last part is, so now we just return the last item of the array, and I guess we'll use the till sum. No, we have to, okay. Let last till equal tills at index tills dot length minus 1, and return, that's kind of, all right. Let's say biggest, biggest till. Return biggest till dot reduce current accumulator current plus accumulator, and I think that should do it. Okay, so now I'm gonna actually go in here. Oh, I commented out my last bracket, my actual real bracket. So now I'm gonna come in here. I'm gonna actually code this out now, and I hope that it works, or at least I hope I'm getting a stab at it. If it's not the most ideal solution. Whew, trying to get some energy back. I started out with a lot of energy, but got a little bit drained there. All right, so what did we do here? So the first thing we did here is we created our tills. So for let I equals 0, I is less than n, I plus plus. For loop, let I equals 0, I is less than or equal to n, I plus plus. So for each of the numbers, and we started at 1, for each of the numbers here, actually what we did first was we created a tills array. Let const tills equals empty array for each one in the right array. For each number from 1 to n, tills dot push empty array. All right, I think that's probably the simplest part of the solution. So now we will go through our customers. Okay, so for each customer, push them to the first item in the array, and then sort the arrays, resort the arrays. For let I equals 0, I is less than customers.length, I plus plus. Customers at index 0. Customers at index, I always mix this up. Tills at index 0 dot, oh my goodness, dot push customers at index I. And then I think I'm going to declare this sort function kind of at the beginning here-ish. I think it's like that. So here's my constant of tills. I'm going to put it right below that. Please let me uncomment this. Okay. That is not correct. Okay, so there's my sort function. And I guess I do apologize for using array.sort on this. It just seems like a pretty long solution as it is. So, all right, so sort, push it to the first, push the customer at I into the first open till, and then sort the tills from smallest sum to largest sum. So tills dot sort. What was our function called? Till sum. And then return the last item in the array. Return tills at index tills dot length -1 dot reduce current accumulator current plus accumulator. Do I not need brackets? I don't think I do. I just want to make sure that it implicitly returns. I think that's right. Whew, okay. I think that's going to be my solution. I'm going to do one little thing here because I feel like it's a big no-no. I'm going to write out. Last thing I'm going to do is I'm going to see if I can write out a merge sort and make it make sense. Just so I'm not just blowing smoke and saying, I know how to do merge sort. Merge sort equals, takes just a single array and if array.length is equal to 1, return that single value array. Else, oh boy, I don't know. Else we want to find the middle of the array. So let mid equal array dot length divided by 2, and we'll wrap that. Oops, math dot floor. Okay. Array dot length divided by 2, and let left equal array dot slice 0 mid, and then let right equal array dot slice mid to the end, and then and then merge. Return merge? Return merge sort left, merge sort right. So I'm going to go ahead and I'm just going to keep doing this. I'm going to do this merge sort, and at the end I'm just going to see how would I understand how it works for numbers. I'm not sure how it works for arrays. Probably shouldn't be too hard. If I just wrote a helper function, const sum array takes an array, return array dot reduce accumulator, current. Is it current? Oh, man, that would be a question to ask. Syntax on a reduce function, is it current and accumulator, or accumulator and then current? I feel like, return current plus accumulator. Why does, oh, there. Like, why is my text editor trying to tell me something? So, sum array. Okay, so here's merge sort, and so const merge. This takes 2 arrays. We'll call them left, right, and they are ordered. Let left index equal left index equal 0. Let right index equals 0. Oh boy. And then while left index is less than left dot length, and right index is less than right dot length. While that is true, what are we doing? Basically, we are, if left at, okay, I'm going to just create some helper variables for me. Just let left item equals left at left index. Let right item equal right at right index. If left item, so we're sorting, just to remind myself, these items, each of them are an array. So if array sum, if some array left item is less than some array right item, oops, ordered, or should I say merged? They're both ordered. Merged dot push left item. Woo. Else merged dot push right item. Then at the end of that, where's the end of that while loop? I think it's here. I think it's right there. At the end of that, merged dot concat we want the remainder. Let me think. We want the remainder of each array. Left dot splice left index dot concat right dot splice right index. Okay, so and the reason for that is when one of these terminates, when one of these things isn't true, one of these indexes will be all the way to the left or to the right. The other one is going to be left with items sitting in it that otherwise wouldn't get pushed to the array. So because this whole thing wouldn't work. But it also means that whatever's on that remainder of the array is by default bigger than everything else, and it's already ordered. So that's why you just push it on to the end. So I'm going to write this out. So I just wrote this out because I feel like you shouldn't. I guess I've always been taught that you shouldn't use these big functions in a whiteboarding. You shouldn't use these condensed functions like array.sort. So I just want to show that I think that's about right. I'm going to comment that out. So now that's my solution. And now I'm going to see if it will pass. Till some. Okay. Let's just kind of look through it one last time, because I do want to get these right on the first try. Till some A, B. Oh, wait. Where's the beginning of the function? Where is it? Okay. Queue time, customers, N. Queue time, customers, N. And let's just make sure that that's, I'm just gonna, I don't know, copy, paste that at the end, I guess, for my own notes. Okay, function, queue time, customers.n, till some, we're gonna create our sort function, constant tills, go through, create 2D array based on the number of n. And then we go through each customer. Push the customer to the first array. How long is this recording? I hope, well, okay. Push the customer to the first array. Sort the array, sort the tills. Okay. Next customer, push it to the first available array, sort the tills. Return tills, last till dot reduce, current accumulator, current plus accumulator. One thing I'll do before I submit this is, one question that I would definitely ask is, what is the array.reduce syntax? I do want to get that right before I submit it. Is it accumulator and then current, or current accumulator, accumulator current? Okay, so let's go ahead and fix that. Accumulator current, accumulator current. Okay, good to know. Technically, I guess that doesn't matter what order that's in. A sum minus B sum. I think that's, I'm pretty sure that's about how you would do it. If A minus 1, if A is bigger than 1, if A is bigger than B, it'll return a positive value. I think that's how you want it to be. Tills is empty, push all of the tills. Reduce accumulator current. So we return the sum of the last item in the array. I'm afraid the complexity is going to fail. So speaking of that, let's talk about the complexity of this solution. Let's see. For each n, we are creating an empty array. So there's that. For each customer, we are pushing, well, we go through the customers list once, but that's still a thing. So I guess that would be, so customers n. So definitely linear in terms of n. Definitely linear in terms of customers. Linear in terms of n, because for each n we're doing something. We're creating the array and then we're sorting the array. Because you would either, I'm not worried about the complexity of till sort, because if it's a large array, then it'll implement something like the merge sort pattern, which will have a log of n. So I'd say the complexity is probably, my hunch is that it's customers times n, because we are, well, is it O of customers or O of n times customers? Hold on, sorry, let me, because we're doing this. So this would be O of customers, right here, this is O of n. And then, we're going through the customers. So I would say it's O of n times customers. Maybe I'm not going to worry about the log of n, log of this part, the sorting, which would be kind of, I guess, log of customers times log of customers. I'm going to say the big O would be customers times n. Okay, let's see if this works. Where's my button? Shoot. I think for the purposes of the video, I don't know if it, well, let's go ahead and see if it works. Run sample tests. Oh, one failed. Where's our error? Queue time? Array reduce. Reduce of empty array with no initial value. Huh. So the array had no value, so reduce. So let's, okay, actually that's a good idea. Yeah, so it failed because the reduce function, I mentioned this earlier, I was hoping that an empty array wouldn't cause an issue, and it did. So where are we gonna do that? So I think pretty much anywhere, I'm gonna have to put a accumulator current. Where does the zero go? I think it goes, darn. I think it goes there. There's something weird about it. Like you don't, I think that's it. Let's try that. I'm not sure if that's syntactically right, but let's see. I hate that. Yeah. Unexpected number. Okay, so that's not correct. That's annoying. I think, wait. I know where the number goes. It goes after the callback function. It goes after the callback function. In this case, we have an anonymous function. Okay, it goes right there. That's kind of weird. Wait, should we put brackets around this? Now I do kind of feel like putting brackets around it because I have this. Let's see. Is that gonna error? Now I don't. Do I need to return now because it's? Yeah, let's do that. Because it's after the callback function. So that is the callback function. Okay. Let's try it. Let's see. Hey now. Okay. Let's submit it. Let's attempt. Woo! I'm really happy about that. I literally almost, when I drew the problem, I was like, I need to stop this because this is tricky. That's awesome. Okay. If you actually watch this all the way through, I appreciate it. I'm really happy it turned out well. I think I've showed that I'm definitely not like pre-staging these. There were lots of mistakes along the way, little things. Anyway, yeah, if you're watching this, thanks a lot. And I should have put a disclaimer in here. If you're doing Code Wars, then if you're another student or just somebody who's doing Code Wars, you should do the exercises before watching any solutions. So there's some spoiler code in here, I guess. But all right, well, thank you so much. And Um, uh, if you're watching this, you have my information. So obviously, I'm really excited to work with a new employer in